All right, picking back up. We have find the derivative of a negative cosecant minus sine. And so we haven't found cosecant yet, okay? So if we go to our handy-dandy cheat sheet and find cosecant, we'll find out that the derivative of cosecant is negative cosecant cotangent, okay? So this negative is coming along for the ride. But if the derivative of cosecant is negative cosecant cotangent, then those negatives are going to cancel out. So I've got cosecant cotangent, and then what's the derivative of sine? It's cosine. So I've got minus cosine, and there's your derivative. Okay, so we're not just learning quotient rule and product rule in this section. We're also learning other trig functions. All right, so now I've got this one. I've got this times this plus this times this. So I've got product rule plus product rule. Okay, so we're going to do the first one first. So I've got the first times the derivative of the second, which is negative cosine, plus the second times the derivative of the first. Okay, so now the first term is done. Now move on. So I've got first, which is x to the fourth, times the derivative of the second, which is a negative sine, plus the second times the derivative of the first, which is 4x to the third. And that's your answer. So when you're griping and complaining and saying, wow, I wish there was a shortcut for this, remember this is the shortcut. Because if I didn't give you the shortcut, you would have to be using the difference quotient, which is the f of x plus h minus f of x all over h, and you take the limit as h goes to 0, and it's a nightmare. And so these are the shortcuts, so just remember that. All right, consider the following. I've got the tangent of x. That's another one that we have not taken a derivative of. So find an equation of the tangent line to the graph of f at the given point. So first of all, I'm looking at the point negative pi over 4, which is about negative 3/4-ish, because pi is 3.14, blah, 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 blah. And then comma negative 1. So this is not a tangent line. That's slicing through 2 points, so that's a secant line, so we know it's not that. This is a possibility, except for my tangent line is way over in the wrong spot. This is a possibility, except for my tangent line is way over in the wrong spot. So it must be this one. Okay, so I've got a negative roughly 3/4, so right there, and it hits at negative 1. So I want the equation of this tangent line. And then, so I've got my x, and I got my y. I need my m. So the derivative of tangent on your handy-dandy cheat sheet is secant squared. Okay, the derivative of tangent is secant squared. So I need to take the derivative, so I get secant squared x, and that's my formula for slope. So now I need to evaluate that at a negative pi over 4. So I have secant squared of negative pi over 4, and I know that the secant of negative pi over 4 is going to be a positive root 2, which it really doesn't matter because it's going to get squared. So the secant of negative pi over 4 is root 2. Square that, and you get a 2. So my slope is 2. Okay? Now, what I need to do is use this slope and this x and this y to find the equation of the tangent line, and I'm telling you now it's going to be ugly. So I've got y equals, so negative 1 equals m, which is 2, times x, which is negative pi over 4, plus b. So this becomes a negative pi over 2. So I've got negative 1 equals negative pi over 2 plus b. And now I need to add pi over 2. So the value for b is a negative 1 plus pi over 2. Okay? And that's where it slices through the y-axis at. So what's your equation of your tangent line? What was my slope? It was 2. And then where does it slice through the y-axis? At negative 1 plus pi over 2. And that is your equation for your tangent line. Sorry. All right. Here we go. So this is called the Witch of Agnesty. I have no idea why, but there you go. So find the equation of the tangent line to the graph at the given point. So my function is a 6 over x squared plus 2. And I need to all right, so here's the thing. If you bring this up top with a negative exponent, with a -1 exponent, the derivative of the inside is not 1. And you're going to learn about that in the next section. So for right now, I'm kind of stuck. I have to use quotient rule. So I've got the bottom, which is x squared plus 2, times the derivative of the top, which is 0, okay, minus the top times the derivative of the bottom, all over the bottom squared. So I get x squared plus 2 squared. And that's the formula for slope. Okay, I'm also given the point 2, 1, so I know I need to evaluate this at an x value of 2. So -6 times 2 times 2 is going to give me a -24. Over 2 squared is 4, plus 2 is 6, squared is 36. So when I reduce that, I get a -2/3. Okay, so my slope is a -2/3, and my x is 2, and my y is 1. So when I slap that, I'm running out of room, so I'm going to write it over here. So if I have y equals mx plus b, I've got a 1 equals -2/3 times 2 plus b. So that gives me a -4/3. So if I add 4/3, 3/3 plus 4/3 is 7/3. So that's your b value. That's where it hits the y-axis. So your equation for your tangent line is a slope of -2/3, and he hits the y-axis at 7/3. Okay? All right, determine the points at which the graph of the function has a horizontal tangent line. So again, we're told some information specifically about the value of the slope that I need, and the value of the slope is going to be 0. So what I'm going to do is take this derivative and set it equal to 0 and solve. Okay, so my derivative is going to be bottom times the derivative of the top minus the top times the derivative of the bottom, which is 1, all over the bottom squared. So that's my formula for slope. Now what I need is to look at this and figure out how to make this thing equal 0. So have no fear, because everybody hates fractions. The only way to make a fraction equal 0 is to make its numerator equal 0. Okay, so notice something for a second. If I shove in a 9 in my denominator, I've got an asymptote there at x equals +9. That asymptote still exists in my derivative. Okay, so x equals 9 is off limits, because that is, no pun intended, because that is a vertical asymptote. So all I have to do is acknowledge where my numerator equals 0 and just watch out so that doesn't rip my face off, okay? So the 2x times x is 2x squared. 2x times -9 is -18x minus x squared equals 0. So my denominator is still there. It's just not worrying me, so I'm going to ignore it. Okay, so what do I have? 2x squared minus an x squared is an x squared minus 18x is 0. So factor out an x, and my two x values are 0 and 18. So at 0, I'm going to have a horizontal tangent line. At 18, I'm going to have a horizontal tangent line. So I need their corresponding y values. Where do you go if you need a corresponding y value? You go back up to your original equation. So I've got 0 over -9, which is 0. Okay, and then 18 squared, I've lost control of my life. All right, 18 squared is, what is going on? All right, 18 squared is 324 divided by 18 minus 9 is 9, and I get 36. So this has a y value of 36. Scared the crap out of me. Hang on, somebody's knocking at my door. Holy cow, somebody knocked on the front door. I almost just wet my pants. All right, so that's that problem. Anyway, here we go. We have, I am on to oh, dang it. I swear, I'm going to get this done. All right, so here's, all right, for 17, we have to look at the graph. So it says I have p of x, and that equals a function times a function. So I bet p means product. And then for q of x, I have a function divided by a function. So I bet that means quotient. And then what it says is find the derivative of this function, the product, evaluated at 8. Okay, so instead of using all of the of x's and stuff, I'm just going to say p equals f times g. Okay, and now I'm going to do product rule. So my derivative is the first times the derivative of the second plus the second times the derivative of the first. Okay, so all I have to do now is evaluate that at 8. What does that mean? So if I look at 8, this is 8, okay? And what I'm doing is I am looking at, if it's just f, I need the corresponding y coordinate at an x value of 8, okay? So p prime of 8 is going to be f of 8 times g prime of 8 plus g of 8 plus f prime of 8. So the f of 8 here and the g of 8 there are simply the y values. But here and here, those are the slopes, okay? So what do I have? I have f of 8 is, so f is this top function, and if I look at where it hits 8, it's going to be at 6. Okay, so the point 6 comma 8. So that's 6. What is your slope of g at 8? Well, that's just a diagonal line, so I can find the slope using algebra. So I go down 1, right 2, down 1, right 2, and so that's a negative 1/2. Okay, now I need the formula, or I need the function's value at 8. So here's my x value of 8, and the value on g is 2. And then what is my slope on f at 8? So my slope on f at 8 is going to be up 2 over 1, up 2 over 1, so it's 2. And now when I clean this up, 6 times negative 1/2 is 3, negative 3, sorry. And negative 3 plus 4 is 1. So the value of this derivative evaluated at 8 is going to be 1. And now we're going to do the exact same thing with quotient rule. So I have the bottom. What I'm going to do is say the quotient is f over g. And so the quotient is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And this time I want to evaluate it at 2. So I'm either looking for slopes or y coordinates at 2. So for g of 2, that gives me a value of 3.5. Okay, so I have 3.5. My slope on f at 2 is 1. Okay, minus my value of f at 2 is 7. And my slope of g at 2 is going to be negative 1/2. So negative 1/2 all over the value of g at 2, which is 3.5 squared. So when I clean that up, I'm going to get a 3.5. I'm going to turn this into a fraction. So 3.5 plus 3.5 is 7. All right, hang on. So you can't see. So 3.5 here, and this turns into a plus. Half of 7 is 3.5, so I get 7 in my numerator. So 7 divided by 3.5 squared in fraction world is going to be 4/7. Okay, so that is 4/7. And I was hoping against hope that I could get this done, and I'm not going to be able to, even though we just have a couple more. All right, so I'm just going to start, and we'll just do these last few in a second.